Hello, today I'm going to do example 3 from section 9-2 part 1. While running some quality control tests, a manager of a chip factory noticed a difference in the mean weight of chips coming off two different production lines. To see if the bags in line A did actually have a mean weight lower than those in line B, he randomly tested some of the bags off each line. Of the 40 bags tested from line A, their average weight was 309.6 grams with a standard deviation of 15.9 grams. And of the 35 bags tested from line B, their average weight was 311.8 grams with a standard deviation of 13.2 grams. If he assumes the variances in the two lines to be different, can he conclude at the 0.10 level of significance that his claim is true? So the part that I underlined, variances in the two lines to be different, that is signaling that this is going to be a two-sample t-test. And we do meet all the requirements for a two-sample t-test. Just make sure you go through and convince yourself of that. So then the null and alternative hypotheses. Well, the claim is that the mean weight from line A is less than the mean weight of line B. So that'll be our alternative hypothesis. So then our null hypothesis will be mu A equals mu B. Since it's a t-test, it's going to be a t-distribution. And since the alternative is less than, it's a left-tailed test, and our level of significance was 0.10, so the area to the left is 0.10. Next, we need X bar A, S A, and A. X bar B, S, B, and MB in order to calculate what the test statistic is. So X bar A was 309.6 with a standard deviation of 15.9, and that was based off 40 bags. X bar B was 311.8 with a standard deviation of 13.2, and that was based off 35 bags. Now I'm going to go over and put this in the calculator. So that'll be test T 2S. Change this to less than for left-tailed test, and then type the numbers in. And remember, because the variances are assumed to be different, pooled will be off. So we get a test statistic of negative 0.65. I'm going to do the critical value method again. So I'm going to do inverse T. I need the area to the right since I'm using a Casio, but if you have a TI calculator, you do need the area to the left, which is 0.10. The area to the right will be 0.90. I also need the degrees of freedom from the calculator. I almost forgot that, which is 72.8. Exit this, you go to distribution, T inverse T, change that to 0.9. It has the 72.8 in there already, so we get negative 1.29. T star is negative 0.65, which falls to the right of that value. So we fail to reject the null hypothesis. Since T star is not in the rejection region, we fail to reject the null hypothesis. Thus, there is not enough data to support the claim that the average weight of the bags of chips on line A are less than that of line B. That is it for example 3.